students, now we will discuss about assignable and chance causes and some variations of ANOVA. In this part, we will be discussing about what is assignable and chance causes, the fixed and random effect ANOVA, variations of ANOVA. So, in the perspective of one-way ANOVA, assignable causes are nothing but the source of variation due to group. So, in the previous part, we have learned about between group variations. So, that between group variation actually we are referring here as assignable causes. So, the variation that has happened due to the between group differences is actually called as assignable causes. In the perspective of ANOVA, assignable causes are nothing but the source of variation due to group. So, in the previous part, we are learning about between group variances. So, that between group variances are actually called as assignable causes. It is sometimes called as systematic differences. Assignable causes are under the control of researcher because the number of groups we wish to compare and the number of observation to take from each of the group is depending upon the research question and the researcher. So, for this we are calling it as it is under the control of the researcher. More assignable causes of variation lead to rejection of your null hypothesis. The concept of null hypothesis will be discussed in the further parts. What is chance cause? Chance cause of variability refers to common or inherent or naturally occurring variability in the process. So, in the previous module, again we have learned the within group variation. So, the within group variation is otherwise called as the chance causes of variability. The researcher has no control over the cause of this variability and it cannot be eliminated, but one can reduce this error. More chance causes leads to acceptance of your null hypothesis. Now, you will be having a confusion. We are actually comparing the means, but why are we calling it as analysis of variance? As the name suggests, we are estimating the within group variance and between group variance, and we are comparing these two estimates. That is why we are calling it as analysis of variance instead of analysis of means. It computes between group and within group variances and whichever is more. So, we can able to say whether there is a difference is there or not. So, by comparing the between group and within group, and if between group is more than the within group, then it is more likely to say there is a difference exists between the means. So, there are many variations of ANOVA. So, such as one-way ANOVA, two-way ANOVA and repeated measures ANOVA. So, I will give you some examples based on the other two types of ANOVA. So, consider the case scenario which we have learned in the basics of ANOVA, that is comparison of three different psychotherapies. So, there we only wanted to compare between the three different psychotherapy and we did not bring any other variables into place. For example, when we are having any intervention and that intervention may work depending upon their age group or depending upon their lifestyle or depending upon their gender. So, if we really wanted to take care of all those variations that is away from our main interest of comparison, then you need to bring into the analysis. So, here two-way ANOVA means we are having one grouping variable or a factor variable for comparison and we have another variable, that is a second variable that we need to control for. For example, when you are having any drugs and you wanted to compare this drug. So, the drug may work differently for different age group people. So, it will work smartly for a adult and it may work little delayed in a elderly people. So, likewise, if you know any particular factor is going to affect your variable, then if you want to incorporate that and the variable which you are incorporating is categorical in nature, then we call it as a two-way ANOVA because we are having two variables which are categorical in nature and we are having one continuous variable which is continuous in nature as we seen in the example. So next we will have repeated measures ANOVA. Here it is repeated measures one-way ANOVA, because one-way ANOVA is missed out means it is called repeated measures ANOVA. So here there is a group, but this group is not an independent group. For example, if you are assessing the treatment, the psychotherapy treatment on a particular group of subjects, and after the treatment you are assessing at the first month, and in the second month you are again assessing the same subjects, and at the third month you are assessing the same set of subject at the third time point. Like that, if your subjects are same but you are measuring the outcome at different time points, suppose you are measuring the working ability score of those set of subjects at 1 month, at second month and third month, likewise you can continue at any number of times. So here this time points become our group. So basically we don't call it as a group, it is a time point, and we wanted to see what is the change that is happening over time in these outcomes. So these are the different variations of one-way ANOVA. We will learn about fixed effect and random effect ANOVA. So by the name, both the models or both the effects are not different from ANOVA, but it is the one of the type of ANOVA. They are not different, but when to go for a fixed effect and when to go for a random effect depends upon the categorical variable and the nature of categorical variable. We will try to understand what is fixed effect ANOVA. So when the researcher is having the factor variable, which I have already introduced, which is a categorical variable, when the researcher make use of only a fixed number of groups or fixed number of factors to compare, then we have to apply a fixed effect ANOVA. In the ANOVA itself, many packages will have two different subdivisions. There you can select, but the methodology and every computations are similar for both of this effects model. So if you are choosing a fixed effect model, it depends upon your categorical variable what you are using, and I said you have a fixed number of groups and they must be predetermined by the researcher beforehand before collecting the data. For example, if wanted to compare different brands of pesticides, suppose pesticide A, pesticide B and pesticide C. So we have only a limited number of levels, that is A, B, C. There is no other pesticides that the researcher wishes to compare. Whereas when you go to a random effect ANOVA, the researchers makes use of only a subset of groups, only a subset of factors, which is a random sample from a large set of groups which he wanted to compare. For example, I said about the brand of pesticides we wanted to compare, that is a fixed effect. Suppose if I wanted to compare the different doses of pesticides, suppose for an experimental purpose, the researcher can come up with many number of doses, for example 10% of dose, 20% of dose, 30% of dose, 40% of dose. So he can have any number of doses, but due to time constraint and resource constraint, he may not trying to put all the factors into place, but he may take only a random sample, say 20%, 40% and 60%. So in between percentage he is leaving out because he has so many options for him to choose. So he is taking a random levels from the existing number of levels. So that is why it is called as random effect ANOVA. So in the second example, if you wanted to compare what is the average number of episodes of diarrhea among different areas, because these episodes of diarrhea will depend upon the different sanitary conditions of the areas. Suppose we have different village areas, we have some divisions, and the researcher is free to choose randomly from any of these areas. He has not fixed the areas which he is going to compare, because it is wrong, because it depends upon the different sanitary conditions. So he need to take randomly the different areas belonging to a particular state or a particular districts, etc. So here the different areas is what is known as the factors or groups if we commonly consider. So, these are the situations we can use for random effect ANOVA. As I said, there is no computational differences between this random effect ANOVA and fixed effect ANOVA. Only the difference is it depends upon the independent variable, that is categorical variable, and you need to take care of it only when you are analyzing the data. In this video, we have learned about what is one-way ANOVA, the case scenarios related to one-way ANOVA, what are the needs to apply one-way ANOVA, some of the basics needed for one-way ANOVA. Then we moved to understand within group and between group variances, the assumptions of one-way ANOVA, how to validate those assumptions, and finally we discussed the unassignable causes and chance causes, and why the name analysis of variance, and fixed effect and random effect model. Thank you. We will continue in the next video.